So the population standard deviation. Moving to this next piece here, and part 2. If you look at the formula, there's a lot of similar things going on. We're still adding together deviations. It's just that the deviation here is using the proper notation for a population. So you have the x minus mu now instead of x minus x bar. Remember, mu is population mean, x bar was sample mean. You also see in the denominator, you're dividing by the population size, the full population size. We don't need to use degrees of freedom to approximate the population better because this one is the population. So that's why they don't subtract 1 here in the denominator. They just divide by n and call it good. And this is a point where I should probably bring up, if you use the wrong calculation in the homework, you'll get the wrong answer, because overall the formulas are real similar. But if you use the sample formula for the population, the sample formula is going to subtract 1 down here, and you're going to end up getting an answer that's too big. So you got to be careful with that, and always pay attention to the word population and sample, or some indication about the type of data set you're working with, because it will change the formula you use. And because of that extra n minus 1 versus the n, it will certainly make the answer for one different than the other. So you got to make sure to use the right one. But overall, you're still adding up all the deviations squared. You're still dividing them by, in this case, n, or dividing by something to get an average amount of the deviations, or the square deviations. And then you take the square root to kind of bring that down to the population standard deviation. The variance is still sigma squared, and you square root the variance to get to the standard deviation. So overall, in this class, I'm going to just save you a whole lot of headache and time. We're going to use technology to compute these. If you were in a face-to-face class back in the day, you would be whipping your hair out because you've been, having to be doing these things by hand, and they're not very fun when you have large data sets. I can tell you that from experience. So you can use your TI-83, 84, graphing calculator, or Desmos. I'm going to focus on Desmos. I'll show you how to use it here just because it's free. You can use it on tests, and I want you to be aware of how it works in Desmos. There is a how-to section in the textbook for the TI-83, 84 starting on page 56. So if you do have one of those graphing calculators, you can look there and get some help on that. You could also probably Google it. There's thousands of videos out there on these things. But before we see an example, I do want you to have a little better awareness of how the variance relates to the standard deviation. And basically, the standard deviation for samples is S, while the variance is S squared. For populations, the standard deviation is sigma, while the variance is sigma squared, lowercase sigma. So find the standard deviation, using technology, and then you just square it to get the variance. So that's going to be a little bit of a twist, because the way I'm going to show you how to do things, we're going to go straight to the standard deviation, and if you need the variance, you just square it. You typically won't find the variance first and then take the square root unless you're doing this by hand. What's the importance of variance? Well, it gets used in higher level stats, as I mentioned earlier. So higher stats classes, to help with certain formulas and proofs. It's just something you would see more of if you went on in statistics. Variance plays a bigger role the higher you go. But for right now, they focus a lot more on the standard deviation when you're being introduced to this stuff. All right, so we're going to look at the following data sets here, and we're going to compute the variance and standard deviation for the set A. And for this one, keep in mind that you're going to be doing the population. So I will have an updated set of notes. I meant to do that before I started recording this video, but it'll say population, variance, and standard deviation. And then for the next one, we're going to do the sample. So we're going to find both of these different ones, the population, the sample one, but we'll do them for the different sets. So I'm going to show you how to do this, and then I'll kind of pause for a second, quote unquote, let you go over to the video. But for the population, variance, and standard deviation, we're going to go Desmos. So this should stay recording. And when we go to Desmos, I've already got it kind of typed in, and you can see here, let me kind of show what you'll start with. So you'll have a bunch of empty windows up here. If you're looking at that data, that's fine. But you want to come down here to the bottom left, and you want to show the keyboard. You want to go over to functions, and then it'll start you out on trig. You want to go over to stats. And there's a whole lot of things in here that we aren't necessarily going to use. But if you notice right here, you see STDEV, like in the third column, third down. And then over here in the first column, 4 down, you see STDEVP. So the one without the P is sample. The one with the P is population. So kind of makes sense. They also have a var here, but they don't have a var P. So what I'll just do with these is get the standard deviation and just square it in order to get the variance for both types. So for the first one in part A, or set A, I just said A equals, and you just type in A equals. And then the reason I'm doing A equals is because then in this second piece here, I can just square the A to get my variance. It makes it a lot easier. So A equals, you type in, or you just select standard dev P, and then in parentheses, you'll need to type in the data set. So larger data sets will have a lot more type in here. But you type in that data set, and then you can see right here, 4.1057. Now for the online homework, go out as many decimal places as you can initially so that you get the correct variance. If you round too low, the variance when you square the standard deviation will end up being not enough. You won't have enough accuracy. So I always go out way more decimals than what I need. So right here, in Desmos, standard dev P, you get that the sigma for the population is going to be equal to 4.1057. Going out 4 places should be enough to get a good variance. If not, you might have to go a little more. And then for the variance, you just do sigma squared. You do 4.1057 squared. And if you look back over here, you can see this is why I labeled this one A equals, and then I just did A squared, and that gave me the number right here. And then you would just round it to what the online formula or the online problem, what it wants. So just keep that in mind. They'll ask you like so many decimal accuracy. So here, 16.8568 after you square that. So we got our 2 values, standard deviation and variance for the population. So go ahead and pause this and try doing the one for the sample. Okay. So again, to do this with the sample, you don't use the standard dev P, you just use the stand dev, STDEV. And I just did B equals, put in the set, and I'm getting here this 4.4347. And then I squared that and got 19.6666. And since I rounded on one in my notes, I didn't end up rounding this up because it was like a 5 then a 6 with the rounding that I did on the original standard deviation. And I just wanted to show you that the variance in this case is the sample one without that P there. It gives you the same thing as if you square the standard deviation. All right, so we'll get S equals, and I did round this here, so that's why my variance won't be exactly the same as if I pulled it off of Desmos. So the standard deviation is S. The sample variance is S squared, and that's just, I'm taking this number and squaring it. And when I did that, I got 19.66656, and then I rounded to get a 6 here. So again, just be careful with the rounding stuff. Go out enough decimals to get the accuracy that the derivative is looking for. All right, so we'll see more with the standard deviation later in this chapter, but for now, let's move on to the next concept. And, looking at percentiles, this shows up, when you were kids, you took tests and you were ranked in certain percentiles. Even, doctors measured you potentially as you were growing up, and, you ranked in certain percentiles for your height and weight or whatever. If you have kids, you may have seen these numbers get thrown around. Oh, your child's in this percentile or whatever. And, it's just essentially a measure of position. So it's used to measure position relative to other data values in the set. It requires the data set to be in order, kind of like when you find the median. Because if you're ranking things, you need some order to the scores. Then the reported percentile would be defined as follows. A value with k% of the data at or below this value. So, for example here, suppose you took a standardized test and your score was given as a percentile. What would a score in the 75th percentile mean? Well, it means that 75% of the test takers were below your score. And more importantly, at or below your score. So a value with k% of the data at or below this value. So they say, oh, you're in the 75th percentile? Well, 75% of the people in this group, or whatever you're measuring and attaching percentiles to, they're at or below what you had for your score. That's all it means. So it's really easy. You see 75th percentile, you just got to remember that means at or below. Everybody else is at or below that percent. So if the test was out of 40 points and you scored an 80th percentile, what was your score on the test? Go ahead and think about this. Let me pause. Okay, well, percentiles can't be used to determine an actual score. All it is a relative standing. There's some really hard tests out there. The Putnam exam, if I remember right, if you score 1 point out of however many points there are, you're already better than half of the people who took the test. It's a pretty brutal math exam. So you wouldn't know if they, you tell somebody 50th percentile on one test, it means you got a score of 1. On another test, maybe that means you got a score of 100. Who knows? So when they ask you questions like this, what was the actual score? You don't know. You just know where you ranked amongst everybody else. So percentiles can't be used to determine actual scores, just ranking. Within scores. Okay, and that'll take us to the end here. We'll pick up in part 3.